Very good morning. Today we are starting a topic arithmetico geometric series. Generally, in this series, the name only says everything. Arithmetico geometric series. First of all, I will say till now, if I take, let's suppose I am taking an AP whose common difference is D and first term is A. Then how can you write the AP? A plus D, A plus 2D, A plus 3D, and nth term I will write it as a plus n minus 1 into d. This is a GP, AP. Now I will take a GP whose first term is 1 and common ratio is r. The first term is 1, r, r square, r cube. And nth term will be r ka power n minus 1. Now I will tell multiply the first term of AP and GP. Similarly, second term of AP and GP, third of AP and third of GP, and last of AP and GP, and form a series like this here: A plus D into R, A plus 2D into R square, plus dotted. Last term I am writing here A plus n minus 1 into D and R ka power n minus 1. Now what name I will give this series is arithmetico geometric series. If any series given and I will tell is it A.G.P, in the short form I am saying A.G.P, then you will see the terms of the series A plus D, A plus 2D. Then you are feeling that it is an AP. Again, the multiplication of A is 1, A plus D is R, yani 1 R, and third term is R square. Then you are saying this is GP. So finally, you are saying arithmetico geometric series, that is A.G.P. Then, how to find the sum of this series? Then, the steps we will use to find the sum of the series. In A.G.P, first of all, you see what is the common ratio of the GP term. Then you will say the GP is 1 R square. Okay, the common ratio of this GP is R. Then, first of all, you will write as it is A plus D into R, A plus 2D into R square, dotted, A plus n minus 1 D R ka power n minus 1. You have find the common ratio of the GP. Then you multiply this common ratio R to the left LHS and RHS of all the terms. Okay, I am multiplying it with common ratio. This become R into S. Again, this right hand side A becomes AR. This A plus D into R multiply with R, it becomes A plus D into R square. Then can we write AR just below it? No, just you write one terms forward. It means shift one terms. A multiply with R, it becomes AR plus A plus D into R. When multiply with R, it becomes A plus D into R square. Means one term you are shifting after multiplying the terms, each terms with common ratio R. Again, I will see this last nth term. Before this term, there it was n minus 1 term. What is n minus 1 term? Then you will say A plus n minus 2 into D. Here R ka power n minus 2, which is n minus 1/8 term. If it multiply, it becomes r ka power n minus 1. And these terms get shifted and it becomes a plus n minus 1 into d, and r ka power n minus 1, it becomes r ka power n. Now I will say subtract this first equation, consider this as a first equation, this is as a second equation, subtract it. It becomes s minus r into s. See here, below nothing is there, a, this gets subtracted, see here, ar plus dr subtracted by ar, it becomes dr. Again, these terms when subtracted, it becomes dr square. Similarly, the nth term when it's subtracted, dotted, it becomes d, see here, d r ka power n minus 1. But here is 0, this gets subtracted with this, it becomes minus a plus n minus 1 d r ka power n. Now this become 1 minus r into s. Now see the right side. This whole term from here till here, it forms GP after you take common d. See here, a plus d, and here it becomes r plus r square plus dotted r ka power n minus 1 minus this a plus n minus 1 d r ka power n. 1 minus r into s, this becomes GP. So use the sum of the GP formula. The first term is r, common ratio is r, to 1 minus r, number of terms. See here, from here to here it is n terms. But if I say from here to here, how many terms are there? You will say n minus 1 terms. So this, the white one which you are seeing, the total number of terms is n minus 1 terms. So I writing here r ka power n minus 1 upon 1 minus r minus a plus n minus 1 d r ka power n. So s is equal to, the sum of AGP is here a upon 1 minus r plus d r 1 minus r ka power n upon 1 minus r divided by 1 minus r, it becomes whole square. This write n minus 1 because this is n minus 1 minus a plus n minus 1 into d r ka power n divided by 1 minus r. This is the steps you have to use always for finding the AGP. Now I will ask, if it becomes an infinite AGP, then how you will do? See here, if it is become infinite AGP, infinite AGP series, it means S is equal to a plus d into r, a plus 2d into r square, dotted, it goes to the infinitive. Again, I have to use the same steps. So before writing again the same steps, I am writing one more term here, that is a plus 3d into r ka power 3. This is a AGP, but these terms I have not to take care about any term because it is going to infinitive. So here first of all I will mention the common ratio should be, mod should be less than 1 and not equal to 0. So if I multiply with r into s, okay, then it becomes common ratio, I am multiplying here, it becomes a into r and I'm shifting it. A plus dr, multiply with r, it becomes a plus d into r square, a plus 2d into r cube. It goes to infinity because infinite terms becomes zeros. Subtract it, 1 minus r into s. When I'm subtracting s minus r is r, this become a plus dr square plus dr cube plus dotted, it goes to infinity. And 1 minus r into s is equal to a plus d, I am taking common, it becomes r plus r square plus r cube dotted infinity. So 1 minus r into s, this becomes infinite GP, whose first term is r and common ratio is r. This is infinite GP. So dr upon 1 minus r. Then s is equal to a upon 1 minus r plus d into r upon 1 minus r ka whole square. This is a sum of infinite AGP. Now in the next lecture we will take the question related to AGP and infinite AGP. Hello, in the first lecture we have discussed of AGP concept. Now we'll take some of the problems related to that topic. The first one is to find the sum of the series. Just see the series. If I say what is the nth term of this series, then first before that I will say, is it AGP or not? The AGP, as we have learned that, see here 147, is it forming AP? Yes. Common difference is d is equal to 3. So I will say write the nth term of this. Say I'm writing the nth term, a plus n minus 1, common difference 3, 3n minus 2 divided by, and what is the nth term of GP will be? So GP is 1 by 5 ka power 0, 1 ka power by 5, 1 by 5 square dotted. So it becomes 5 ka power n minus 1. Now what is the step? So GP common ratio is multiplied. So common ratio of GP is 1 by 5. I multiplied s by 5, this 1 by 5 ka power 0, which is 1, it becomes 1 by 5. This 4 by 5 becomes 4 by 5 square. I have shifted and writing there. Again, this 7 by 5 square when multiplied by 1 by 5, it becomes 7 by 5 cube dotted. If I ask what is the term just before this, then your reply will be common difference is 3. So subtract AP with 3n minus 5, and GP n minus 1 term will be 5n minus 2. When I multiplied with 1 by 5, then it becomes 3n minus 5 divided by 5 ka power n minus 1. And this term gets shifted, 3n minus 2, 5 ka power n minus 1 when multiplied by 1 by 5, it becomes 5 ka power n. Now I subtract these two terms. What it becomes? 4s by 5. See here, this is 1. This is 3 by 5. 3 by 5 square. 3 by 5 cube. Subtraction I'm doing. Okay now? 10 minus 7, 5. 3. And divided by 5 ka power 3. And this one become 3 upon 5 ka power n minus 1. See here, this become minus 3n minus 2 divided by 5 ka power n. Now I will say, if you take common 3, then the remaining term is 1 by 5 plus 1 by 5 square plus 1 by 5 cube, and it is forming purely GP, 1 upon 5 ka power n minus 1, but number of terms is n minus 1. And first term is 1 by 5, common ratio is 1 by 5. Then 4s by 5 is equal to 1 plus 3. First term is a 1 minus r 1 by 5 ka power, writing n minus 1 because formula says a 1 minus r ka power n upon 1 minus r. And 1 minus 1 by 5 I'm writing directly 4 by 5 minus 3n minus 2 divided by 5 ka power n. So s, before s, let's simplify this. 1 plus this 5 and this 5 will get cancelled. 3 by 4. When multiplied with 1, it becomes 3 by 4. Minus 3 by 4 into 1 upon 5 ka power n minus 1. Minus 3 and minus 2 upon 5 ka power n. So s becomes, this becomes 7 by 4. 7 by 4. 5 will divide to 7 into 5. Let me write first. This 4s by 5. And this becomes 7 by 5. 4. Minus 3 by 4. 5 ka power n minus 1. Minus 3 and minus 2 divided by 5 ka power n. So s will become 35 by 60 minus 15 by 4, 5 ka power n minus 1. You simplify it by dividing with 5. And this becomes 5 by 4, 5 ka power n into 3n minus 2. You can further simplify it. Or I can say this is the answer. Now, come to the question number 2. In this, we are taking infinite A.G.P. If you see, s is equal to 1 plus 2x plus 3x square, 4x cube dotted up to infinity. Mod x is less than 1. Now, I will say if you, what is the common ratio of GP in this series? So first of all, you have to find the GP. So which is GP? Then you will say 1 and this x square and this x cube. This is forming a GP. So what is the common ratio of GP? You will say it is x. Again, you will multiply with x to the left and the right, but right side the terms are get shifted by one terms. It becomes x, 1 into x. 2x become 2x square. So I am writing here 2x square. 3x square become 3x cube. And this is infinite GP. So I am not taking any stress on the nth term, anyone, but I am writing infinite. It is going to be infinite. Now I am subtracting this. What it becomes? 1 minus x into s. Because in this I can take s common. So this is 1 and minus x. What it becomes? It becomes 1 plus x square plus x cube plus dotted. It will goes to infinity. So infinite GP formula I will use. What is the infinite GP formula? A upon 1 minus r. A is 1. Common ratio is x. 1 minus x. So s becomes 1 upon 1 minus x whole square. So this is the answer of this question. Now, let's take the question number 3. If the sum to infinity of the series 3 plus 5r plus 7r square dotted infinity is 44 by 9, then value of r. Again, if you see, this is A.G.P. How? Then you again say 357 is AP, 1r, r square is GP, so A.G.P. So common ratio of GP is r. Again multiplied both sides by r, so it becomes r into s. This 3 multiplied with r, it becomes 3r. 5r multiplied with r, it becomes 5r square, and it keeps on increasing infinity. Now subtract it. When I subtract, what it becomes? 1 minus r into s, because this is 1, and what this becomes? 3 plus 2r plus 2r square. It keeps on going. 1 minus r into s. 3, take common 2, it becomes r plus r square infinitive. This is the sum of infinite GP formula. I have to use it. A upon 1 minus R. So it becomes 3 plus 2. This R upon 1 minus R. 1 minus R into S. And S is equal to 3 by 1 minus R plus 2R upon 1 minus R whole square. Sum of infinite GP is A upon 1 minus R. Now, if I simplified this one, see here, 3 into 1 minus R plus 2R upon 1 minus R whole square. I am taking 1 minus R as LCM. So, 3 into 1 minus R plus 2R. So, it becomes 3 minus R upon R square minus 2R plus 1. And its value is given 44 divided by 9. Multiply it. So, it becomes 27 minus 2, 9R. This becomes 44R square minus 88R plus 44. 44R square minus 9 will come here. It becomes plus 9R. So minus 79R. This 27 comes here. So it becomes 17 is equal to 0. See here, 44 means 11 into 4 and this is 17. 17 4 ja 68 into 11. Okay. This becomes 44R square minus 11R minus 68R. That is 79R plus 17 is equal to 0. From here I am taking common 11R. And from here I am taking minus 17 common. So what will be the remaining? It will be 4R minus 1 is equal to 0. So R value is 17 by 11 and R value is 1 by 4. This is the answer of question number 3. Now let's solve question number 7. Find the sum again to the n terms of the series. Again this is as I am writing as S is equal to 3, 5, 7. This is AP. So nth term will be 3 plus n minus 1 common difference 2. So after simplifying it becomes 2n plus 1. So I'm erasing this and saying 2n plus 1. Now see, this is 1, this is 4, this is 4 square, this is GP forming. So nth term will be 4 ka power n minus 1. Just below this, before this, 2n minus 1 upon 4 ka power n minus 2. Now I come from here that the common ratio of the GP is 1 by 4. So I will multiply with 1 by 4 in every terms of left and right. But right side again gets shifted. And I am writing 5 by 4 into 1 by 4. It becomes 5 by 4 square. And it keeps on coming here. 2n minus 1 when it multiplies with 1 by 4. 4 ka power n minus 1. It gets shifted. 2n plus 1 upon 4 ka power n plus 1. Now I am subtracting s minus s by 4. That is 3s by 4. This is 3. This is 2 by 4. This is 2 by 4 square dotted. This is 2 upon 4 ka power n minus 1 minus 2n plus 1 upon 4 ka power n. Now see, this 3s by 4, this is 3, I am taken common 2, it becomes 1 by 4 plus 1 by 4 square dotted 1 upon 4 ka power n minus 1 minus 2n plus 1 upon 4 ka power n, because here it is a 0, so 0 minus this minus. From here I can say 3s by 4, I can simplify it 3 plus 2. First term is 1 by 4 minus 1 by 4. Number of terms, see here, number of terms from here to here, it is n minus 1. Okay, not n minus 1. So divide by 1 minus r. 1 minus r means 1 minus 1 by 4, that is 3 by 4. minus 2n plus 1 upon 4 ka power n. So I can write it like this: 3, this 4 get cancelled, and this becomes 2 by 3 minus 2 upon 4 ka power n minus 1, and this again 3 will be here, 3 minus 2n plus 1 upon 4 ka power n. Now as I can write it here, this becomes 11 by 3 and 44, because s is 3 by 4, 4 by 3, I have divided it, and I say 11 by 3, the 3 by 4 I am dividing, the 44 by 9 minus 2 upon 3 square, and this 4 goes up, so it becomes 2 becomes 8 into 4 ka power n minus 1. Again this becomes 4 by 3, you simplified it, 2n plus 1 upon 4 ka power 1. I have to just see the